Okay, yeah, I just started recording now. So, all right. Good evening, everyone. Once again, welcome to another session in blockchain awareness web 3 bootcamp. Last week we started the class on NFTs. We went through the theoretical part of NFTs. We looked at what NFTs, the importance, the ecosystem, and so on and so forth. Right. We also took a tour through OpenSea. Going to be doing some practical session, right? We're going to be writing and deploying our first NFT smart contract, and we're going to, if time permits us, right, we're going to go as far as adding it to our wallet so you can see your own NFT in your wallet. And we're going to do it in such a way that every single person is going to mint an NFT, which should probably be like a proof of attendance for this particular class, right? Before, without further ado, right, let's just get started. So I'm just going to share my screen. Mm, okay. Mm, okay, you guys can see my screen, right? Fivo, you can see my screen. Okay, but Victor and Sumto can't see it. So maybe Fivo, you probably need to have to check your network. Okay, so I'm going to okay, let's just head somewhere, or let's just start somewhere here. So we're just going to start with creating a new project. Let's call this NFT minting class. All right, I'm just going to copy this into my terminal. Okay, let's expand this. All right, we'll start with initializing npm, creating an NFT class. Okay, description. Let's just keep this. Let's just keep this. Let's just keep this. Let's just keep this. Keywords. Let's go blockchain and then here. Right. Yes. All right. To create a new package, right? We could just open this in our code editor. Yep. Okay. So I'm going to go ahead to install Hardhat in this particular folder, right? And we've already gone through this in the previous classes. So we're going to run npm install save dev Hardhat, and that's going to take a couple of while, but we should have that installed and we could get started soon. Yeah, so I think a few persons previously asked if we could install hard hats globally, right? And the answer is no. You probably most times want to install hard hats with every single project you get started with, right? It's unlike truffle, you cannot just install it hard hat and maybe those want to like hard hat in it anytime you start a new project. um but something you could do, right, if your goal is like to conserve your data, to preserve your data, right? Something you could do, which I used to do when I got started, right, was I could install it in a project, right? Something like a boilerplate. I would install it in a project, like in a particular folder, which would serve as a boilerplate, as a starting boilerplate for all my Solidity projects, right? And then I'll just copy it into a new folder, I'll rename it and start a project. Although that's also a little bit stressful because before you would copy it from one folder to another, of course, that's going to take a lot of time. But you have to sacrifice one, right? Either you save time and consume data, or you preserve your data and consume time. All right, so we just have we just installed Hadout, right? So we're going to go ahead to run npx Hadout to start a new Hadout project. And so we're going to get this option. We're going to create a JavaScript project. Yes, yes, yes. Okay. So, so it's going to install the project dependency autonomic foundation slash Hadout toolbox. We just have to wait for this to get completed. Let's see if there are anybody trying to get in without meeting. Yeah, gotcha. Yeah. All right, that's completed. So the we have like two more packages we want to install. First of them is we're going to be needing the .env package, and we are also going to be needing the Open Zeppelin library. So today we're going to take a brief walkthrough through like the Open Zeppelin library, why it's important, and how you can use it in your project. So to install Open Zeppelin library, right, you can access it from at Open Zeppelin slash contracts. So we're going to install these two dependencies. Yep, now we have our Highlight project set up and ready to commence, right? So, we're going to go into our contract folder and we're going to replace log.so. Let's just rename this to like, we're going to be calling our NFT, what do we want to call it? Um, let's call it, um, Brothers Dev NFT, right? Let's call that because you guys are Brothers developers. So we're going to call it Brothers Dev.tool. All right, and we're just going to clear all this. So we're going to be writing our NFT contract inside here. But before we do that, right, I would want us to take a little thought through Open Zeppelin libraries basically. So I'm just going to see if we can find. Let's see Open Zeppelin. Glow is still not the best. No, network today is such a thing. So Open Zeppelin, I think it's like a security audit company, and they have like a set of secured and well audited libraries which they create for slightly different programming languages, right? And can be very effective when building smart contracts. So the essence of a library, right, is imagine if what you want to do, right, has been done by another person already. So the beauty of programming, right, is like I've forgotten what it's called, right? But then you should be able to like inherit another developer's work, or um if someone has implemented something you want to implement already, right, there's no point like rewriting that whole stuff from scratch. You could just simply like get import that library into your project and probably use certain functions from the library. So that's what Open Zeppelin does for the ecosystem. Basically they provide a set of well audited libraries that contains different smart contracts and tools that you can import into your project and basically use without having to rewrite it. For example, remember how we had to rewrite the whole ERC20 contract from scratch, right? Now, Open Zeppelin already has the ERC20, well-dated ERC20 contract written, which also implements different functions such as mutable, possible, burnable, and so on and so forth, right? So rather than write that from scratch, you could just simply use their own contracts which has already been created and which you trust to have been audited, right? You can just import it and just use that instead, and maybe just call functions. I think we in blockchain UNN repo we have okay. So I was supposed to like create this trying to work on a combination of little smart contracts which you could use for learning, but I've been a bit lazy to like really work on this. But if you go to the main ERS20, right, you'll see that for the ERS20.soul, there was no need to rewrite everything from scratch, right? I just had to import Open Zeppelin, and then within my contracts, right, I just within the constructor, I just inherit. So with I don't know if Stanley touched on this, right, but with Solidity we have the concept of inheritance. So you could basically inherit another contract, and basically by inheritance it means that once, like for example, the token contract inherits ERS20 contract, every single function contained within this ERS20 contract becomes available within the token contract. So basically we just call the constructor, passing the name, symbol, initial supplier, blah 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 blah, which we also use to initialize the constructor of the ERS20 Open Zeppelin library. Let's check out the library. Um, let's head to Open Zeppelin contracts GitHub. Yes. Yep, so within this GitHub repository, right, you can find every single contract that is contained within the Open Zeppelin library, which you could import and use. So there are contracts for access restriction, for finance, for governance, for interfaces. So the interfaces of the contracts, right, for meta transactions, proxies. So our focus for today is going to be on tokens, right? So you could just simply head to, if you head to the RS20 contracts, let's forget about the extensions. So we're just going to look into the RS20.soul contract. So when you go through this contract, which I will advise you to definitely go, because if you go through it right, try to like something I used to do then, right, was I go through their repository for every contract I want to implement, like I want to inherit, right? I just check it out, try to like rewrite it, and somehow you like just get better basically by doing something like that. You probably run into some functions or whatever that you don't understand. You make research, you learn from there, right? So, but within the RS20, so you can see that this particular contract is a proper RS20 contract that implements most of the functions we implemented in our previous RS20 contract, which we wrote from scratch, right? So as you can see, there's a name function, there's a symbol function, there's the decimals function, there's the total supply function, balance of function, transfer function, allowance function, and so on and so forth, right? So we don't have a lot of time to like go through this individually, but because these functions are already built in, right? You already, that's why it's called a library. You already have those. The contract is already written, right? So you could just simply within your contract, you could just import this. You could basically just import this, and within the constructor, right, you want to call the mint internal function and pass in the recipient and the initial supply. And when you do that and deploy this particular contract, right, you can see you don't need to implement other functions. But when you deploy this particular contract, you would see that every other function that was contained within the Open Zeppelin ERS20 contract will be imported automatically by the compiler into this token contract. So that's like the beauty of libraries, right? That's why I said for the assignment, if you can use libraries, is anybody trying to? If someone said I should zoom in, yeah, think of it like yeah, you could say it's like Bootstrap. Like can you, yeah. Yeah, I think you could say it's like Bootstrap basically. So let me zoom in. Let me zoom in. All right. Is this better enough, Vivo? Just charge this thing because I don't even taking the slides. If the font size I am currently using is like better, please just let me know in the chat. I can't hear from Vivo. So But let's continue. Don't have time. So yeah, so basically we're also going to be using Open Zeppelin libraries for our ER721 contracts, right? So if you go back into the token, you could see there's also an implementation for ER721 and I think ER1155. So but we're going to be focused on ER721. Now if you're into ER721.2, right, because we're going to be inheriting this contract, you can see it contains some of the functions which we talked about. So I remember on Sunday we went through the EIP 721, right, and we showed you some important functions that an NFT contract is supposed to possess, rights functions like balance of for checking like the owner of a particular token, the owner of for checking the owner of a particular token, the balance of for checking the balance of and a particular owner, right? The name function, the symbol function, the token URI, the get approved, the set approval for all. This is approved for all, which I believe that we have not already forgotten the use case for most of these functions, right? So because of time, if you I would encourage you to go through this particular contract, right? Of course it's big and it's complex. If you have questions, you have a particular line of code you don't understand, ask on the group chat, the few group chats, and you're going to have someone attend to your questions. As you do that also, you could probably have the EIP 721 the EIP 721 basically by your side, right? You could just open it and by the side, and probably if you forget a use for a particular function, you could just check the specs again or the interface, right? I think it was properly commented, and basically find whatever you're looking for. Or so to get started, right? We are just going to start with specifying our code license, obviously. We're going to use MIT. Then we're going to start with Pragma Solidity 0.8.0, which signifies the compiler that uses Solidity smart contract. Then we're going to import some things from the Open Zeppelin library, which we installed earlier. So from Open Zeppelin right slash contracts slash token slash ERC721. I'm going to import the ER721.2. I'm going to import this particular contract. Our contract is going to inherit this particular contract, right? ER721.2 from the Open Zeppelin library. We are also going to be importing from Open Zeppelin. I don't know why I did. For my part. Okay, slash contracts. I think in token, right? That should probably be ER721. So within the, I think, extensions, you want to import the ER721 URI, if it's URI storage.soul. Then we are also going to be importing a particular utils, right? That's going to help us with increasing or decreasing like the token ID of our NFTs. So we're going to take a quick stream through some of all this library so that we could probably understand what they are doing. We're going to be importing the counters also. So let's start with the ER721 URI story. Let's see what that particular contract does. So if you head back to Open Zeppelin, right, to check out ER721. Okay, no questions. You check out ER721, right? You go into the extensions and you check out the URI storage.soul. So as you can see, the two most important functions to us within the storage contracts right now is the token URI function and the set token URI function. Now, basically, this token URI function can be used to like return the token URI which was set for like a particular NFT, and the set token URI is what we're going to call is the function we're going to call like to set the token URI for a particular NFT. So I've been saying token URI. I don't know if any of us still remembers what a token URI is from like our previous class. Anybody, anybody want to help us? You could unmute your mic and speak or type it in the chat. What's like a token URI? Just to confirm, we actually like probably went back to read up on NFTs, or we just left everything till like the next class. Anybody?
So what's the question?
I was asking like what is like the token URI. So we mentioning token URI. What's like the token URI?
So I think the token URI is like the link given to us by one website like that we post pictures so that we can put the link inside our contract.
Okay. Okay, that was a great attempt. Any other person? All right. It seems like it's only good in the went back to check up on NFTs after our previous class. So basically I remember saying this in our previous class, right? I said that when you see an NFT, right? Let's check out OpenSea again. Check out OpenSea, OpenSea.io. Now, if you check an NFT, right, like any NFT collections at all right, let's check out this particular collection, Synaptica. My network is slow, so I'll wait for the network to take the whole world to load, right? Basically, NFTs have what we call traits. Do you get? Remember when I said when we talked about use case of NFTs, we said that NFTs can be used to like represent reward assets, can be used for artistic works, can be used to represent different things for gaming, for this, for that, right? So the thing that differentiates different NFTs, right? The thing that differentiates one NFT from the other is the NFT trait. So let's say I want to put an NFT of myself online, right? An NFT that represents me online. What do you think I'm going to put? I'm going to put things like my skin color. Okay, I'm dark toned. Okay, what's the color of my eye? Okay, I have brown eyes. I have black eyes. What's the color of my hair? Okay, I have black hair. Okay, what's my height? What's my this? My that? These traits are unique to every NFT. These traits are what makes NFTs unique, right? Now the question is, how do we represent these traits online? So, for example, if you go to a particular NFT, if you go to a particular NFT, right, you should be able to see the traits. So as you can see here, here are some traits like the artist and the title. And these are just like this was like just the traits here is actually very basic, right? But there are some NFTs you go to and they would like actually for like gaming the ones that are used within the gaming ecosystem, right? And you see down to very little details like the size of the gun, the amount of bullets this particular NFT can carry, just different traits basically that describes that particular NFT and that differentiates it from other NFTs within the collection. So how do we do this, right? We do this using what we call a token URI. So basically a token URI is a string is a string basically or a URL that links to like the metadata for this particular token. So the metadata, so all the traits basically all those things are called a metadata. We represent them using a JSON file, and so basically, the URI should link to that metadata. That's what specifies the traits for that particular NFT. So it's very important for every NFTs. We're going to understand this as we probably go forward, right? Now we're going to okay, so we're looking at these functions from the Open Zeppelin library. So basically the set token URI is what we're going to use to set like the the URI that links to our, should I see, the storage position of our metadata that describes our token traits, right? Our NFT traits. The token URI can be simply used to get like the what's it called, the URI for that particular NFT, right? The metadata for that particular NFT. So the next thing we want to look at, right, which we are importing. The next thing we want to look at, which we are importing, is the counters.soul. I don't know. Is this my font size? okay, or do you guys want me to increase it more? Let's see. Though I think this should be okay. Let me increase it by 117. All right. I think this should be perfect for every eyes. This is good, right? No one's replying me. Well, move. So, if we go back to let's go back to our contracts, right? You should have the utils folder, which contains like different utils that you could probably use within your Solidity contracts, right? So we're going to check out the counters. So where's that? Oh, has it been moved? It's actually supposed to be somewhere here. It's been a while. Let's check this out. I think this gives you the ability to find. Let's see. Counters. Repo counters. Let's see here. Mode. I seem to unable to currently find where that is. Let's see if it's in math. No. Right. I currently can't find where that is, but when I do, I'll probably let us know. Still not here. I think it's somewhere. Also somewhere. Yeah, well, just not to waste time, right? I'll probably check it out and I'll let us know where that is. All right. So, but basically, to explain what the counters does, right? Counters is like a simple open Zeppelin library that can help you like manage, let's say, indexing, right? So with counters have like I think a single storage variable which you can use to store the value of the id or the index, right? And you can always increase that index by one, so using increment. I if I think there's the, let's see, counter dot, so let's see, open the plane stuff. Yep, so basically it's like let's see. Yeah. So there are three major functions within the counters contracts or the counters library. So it's basically provide counters that you can only increment or decrement by one, right? And you can also reset. So you have the current. The current returns like the current value of the counter. So the counter is like, think of it like an ID which is stored in the storage, and you can always increase the storage ID by one or decrease it by one, right? So but when you call current, you the current value of that ID. Call increment, right? You increment the value by one, and when you call decrement, you decrement the value by one. So we're going to be using that to like increment the ID of our token each time like the user wants to meet. So the next ID of the next NFT that's going to be minted is going to be one above like the previous NFT that was minted. So I think someone wants to get in. Right. So we are just going to start with specifying our contracts, right? So we're going to say contracts. We're going to call this. Let's call this brothers dev, and this is going to inherit the ERC721 URI storage, and we're going to proceed from there. So you're going to be wondering why I did not inherit this and inherit this, right? So the thing is, the way inheritance works, right? Like I said, if you inherit a particular contract into another contract, right? All the functions available in that contract becomes available in the contract you imported into, right? So if you check ER721 URI storage, you'll see that ER721 has been imported in it. So since it has been imported in here, it means that if we call this, right, you'll automatically also have access to this. Let's just check the repo to confirm, right? So if you head over here, you're 721, you check extensions, check your right storage, right? You would see that this has been it inherits ERC 721, And so automatically by inheriting ER721, we already have access to like all the functions that are contained within this ERC721. So we have all access to all the functions contained within here. So we what we're going to do now is we're going to see using counters dot counter, right? So let's just using counters for counter dot counters. Right. Sorry, counters dot counter. I'm always mixing this. Okay. So next up, what we're going to do is we're going to specify our constructor. That's why we have this error, right? It says no arguments passed to the base constructor yet. So we're going to specify our constructor, and we are not going to pass any argument into our own constructor. That's the constructor for this particular contract, right? But the ERC721 contract also has a constructor, and if you check the ERC721 contract, right, you see that the constructor takes in two things. It takes in a name and it takes in a symbol. So we'll have to pass in the name and the symbol into this particular constructor. So for our name, right, we can call this name of our token is going to be called brothers dev, and the name of this token symbol can just be we're going to call it BDD. Let's just leave it like that, BDD. Yep. All right, so we are not going to always leave the constructor body empty since we don't have anything passed into our own constructor. So automatically, there's nothing really we want to do within our constructor, right? So we're going to add a single function. Now, this function is what people what who are going to be minting our NFT is going to use to mint this particular NFT, right? So this function is going to be called mint, and it's going to take two parameters. So we're going to take the recipient address. We're going to take the recipient address, and we're going to take in the token URI. So that's going to be a string memory. Token URI, right? And this is going to be public. It's going to be a public function. I want to return the token URI, which is going to be in 256. Okay. Now within here, what do we want to do? So one more thing we can do here, right, is we're going to initialize this counters. That's counter. It's the private ID. We're going to call this token IDs, right? Yep. So in here, what we want to do, right, is we're going to each time this function is called, the main function is called. The first thing we want to increment is like we want to increment our token ID. So we're going to say token IDs dot increment. We're going to call the increment function on the token IDs interface, right? So we're going to increment this, and after incrementing this, right, we can now say that our new token ID is in ID of the new token that is going to be minted, right? We could say that it's going to be equal to, if you call token IDs dot current. Remember that we are actually using this particular library of contracts, right? And that has three functions: increment, decrement, and current. So for this particular contract, we're going to be using just increment and the current. The increment increments the token ID by one. So when you initialize, when you deploy this contract, right, the value of the token ID is going to be like zero. So when you increment by one, right, if you call token IDs, it's going to return a counter of one. Now this one is going to now be the ID of the new token. So that's why we call current. So current is going to return the current token ID. Having done that, we are just going to call our main function. So our main function is an internal function contained within ER721. So if you go in here, let's just search. This is our search, right? What did I just do? Okay. This is our search, and we're going to search for mint. So this is the function we are calling, right? The min function. And as you can see, it takes in an address to and a token ID. So this is the particular function responsible for minting this NFT. So we need to take note of the arguments it takes in. So we're going to call the main function and we're going to pass our address to is going to be the recipient. And our token ID is going to be the new token ID. All right. Then the last thing we are going to do, right, is we are going to want to set our token URI. Remember, like this is like the trait of the contract, so we need to set it in order for this contract NFT to have some unique features, right? So okay, I'm going to call the set token URI, which you could find if you go into the extensions. Check it, ER721 URI storage, right? I want to call the set token URI function. So what does this function, what are the parameters we need to pass? We need to pass in the token ID and we need to pass in the token URI that we are setting, right? So we are going to call the set token URI function and we want to pass in our token ID, which is new token ID. And finally, we want to pass in the um, token URI, which we get from like the arguments, right? So we're just going to pass in token URI, okay, and that would set the token URI for this particular function. Finally, we are going to return our new token ID. Remember, we have to return it, so we're just going to say return new token ID. And as you can see, just with a few line of codes, we already have like a fully functional NFT, right? A fully working functional NFT. And while it looks like a few line of codes, right, you'd be surprised at how many files or how many functions will be contained within this small contract from all the contracts we've inherited. So if you check all the functions you can see here is contained in here, all the functions from ER721 URL storage, all the functions from counter.so. So let's try to compile this contract and see if we are going to run into any errors. So we're going to head to our terminal and to compile the contract, we're going to run npx harder compile. All right, I got kicked out and I didn't even know I got kicked out till now. Network is so horrible this evening. You guys should have at least informed me on the group chat now. Can you guys still hear me?
Yeah, I can hear you. I can hear you.
Um,
Yeah, I can hear you, sir.
long since I stopped talking. Can you guys see my screen now?
Yes, sure.
Yes, yes, yes. Fine.
Right. So, can you guys please let me know where you lost me so we could just start from there again because I have different company contract work.
We lost you when we were trying to compile the harder code.
Very sorry about that. Like, LinkedIn is really messing me up. It's not even helping matters. Right. So I compiled the contract right using MPX hard as compiled, and the contract was compiled successfully. So I was saying that for people who probably ask, we just have one Solidity file. How come it's compiling Solid 17 Solidity files? Remember what I told you about inheritance? So we inherit different contracts. So we inherit three contracts. If you check out these three contracts also are inheriting different contracts. So like as you can see from here, you can see this particular contract itself inherits like four different other contracts, right? Your 721 contract also inherits different contracts and so on and so forth. So the Solidity compiler has to compile all inherited contracts to ensure that there are no errors in any. And that's why you have compiled Solid 17 Solidity files while we just have one file in here. I don't know if you understand that. So I was asking, are there any questions as to the contract? We are running out of time and there's still a lot we need to do today. So do we have any questions?
Yeah, sir, mine is showing compilation fail.
Yours is showing compilation error.
Yes, undeclared identifier.
Undeclared identifier.
Yes, underscore token IDS dot current.
Okay. So I think you have probably missed something. Did you declare? I think you didn't declare this, right? Did you declare
Okay,
this?
yeah, that's true. Yeah, that's true.
You didn't declare it, so you're supposed to so basically it's an interface for this particular library, right? So you need to declare this one, and then after you declare that, you can now call the increments and current function.
So, sir, please, can I see your code again?
You could take a look at it. Although I would, all these stuffs are in case you miss anything, right? You could just head over to blockchain UNS repo, right? Check out the within the contracts, check out the mean ER721. You find everything in here. I'm just paste this here. So when I have time, I'm going to update that repo, right? I wanted the whole idea was to create minimal implementations of different standards and protocols in Solidity, which could actually aid your learning. But I've been really, really super occupied to do that. I'm going to find time to do that. So you could probably start the repo and probably check out some of those things we've talked about. Yeah, so because we are running out of time, we are now going to start with our deploy script. So I think one of the things a lot of us complained about, right, was writing deploy scripts, deploying our contract. We really do not know how to do that. And I said in our classes, INT classes, we're going to take time to go through how we can write deploy scripts and deploy your contracts to Ethereum. Okay, so the first thing we are going to do, right, is we already have the .env what's it called package installed, right? So we need to create a new file called .env. Now the reason why you need this .env is because one of the mistakes that a lot of developers make that have cost a lot of protocols millions is the mistake of moving your private key to GitHub. It's something you do not want to do because once you move your private key to GitHub, it is automatically compromised. So people have GitHub bots and GitHub crawlers that crawl GitHub just for private keys alone. And once a private key is cited, your wallet is sniped even without you. Before you can correct everything, everything in your wallet is gone. I made that mistake once, and trust me, it's not something very funny. So you need to the essence of it of the .env, right, is usually used to store what we call environmental variables, which are variables that you use within your contract. Environment variables you use within your contracts, which you don't want to expose to the outside world. So when you use the .env, right, you need to go into the .gitignore and add the .env to your .gitignore. Now, if you used Hadat, right, and you choose the option to add .gitignore by default, you should have your .env added here by default. But if not, add .gitignore to your file and add the .env there, the node modules there. These are very important, right? You do not want to move your private key to GitHub. That's like one of the worst mistakes you could ever make as a developer. All right, so there are also different other options, right? You could pass your, I think Hadat gives the option to pass your private key as a terminal variable, right? Which is I think is considered the safest, but the CNV is also very safe. You just need to be very careful. Now within this just ENV, we're going to be specifying three things, right? So we're going to be specifying our Sepulia RPC, which is the we're going to be using Infura. You can use Alchemy or whatever RPC provider you decide to use, right? But the RPC stands for remote procedural calls, right? And this is what we're going to be using to like interact with Ethereum. So we have RPC providers, big RPC providers that are run nodes, right? That you could interact with. So thanks to them, right, you don't have to spin up your own node to like interact with Ethereum and so on and so forth, right? So we're going to be needing three things. We're going to be needing Sepolia RPC. We're going to be needing your private key. We're going to be needing your private key. And finally, we're going to be needing your Etherscan API key because I want us to learn how to verify our Solidity contracts right from using scripts. So we're going to need the an Etherscan API key to do that. And I'm going to tell you how to do that, but I'm not going to fill this because if I do that, someone here will go and steal all my 100 Ethereum I have in my wallet, right? So I have to safeguard my wallet. So these are just fill this in, create a.env, fill this in, and I'm going to show us where we can get each and every of this information from. All right. So first off, for the Sepolia RPC, so we're going to head to Infura. So you can find Infura at infura.io. Head to Infura, click on Get Started, click on Get Started. Okay, so oh my god, let me see. You said you have a question? Someone was saying something. Who's that? Okay, yeah, Chit baby, you can unmute your mic and speak.
Like for the concept of yes, it's me. Is where somebody uploads the code to GitHub, and because the private key is there, is exposed and they got stolen. Is that where security comes into play? Like learn about how to secure your wallet in blockchain security. Is it where it comes into play?
Yeah, that's like one of the first steps towards
Hello?
blockchain security, right? You need to yeah, that's like one of the first steps towards blockchain security. You need to protect your wallet with your life. Like you need to protect your wallet with your life unless you lose everything you have, right? So you want to make sure you never expose your private key to the outside world, right? And that involves ensuring you do not move it to GitHub because that's a mistake a lot of developers make starting out, right? So to do that, like I said, create a .env file, put your constants, that's your three constants, your Sepolia RPC, your private key, and your Etherscan API key inside here, and add this file to .gitignore. What .gitignore does, I believe we already know how to use GitHub, right? But what .gitignore does is it ensures that you do not move any private information, any private variable rights to GitHub. For example, you also do not move node modules for big folders and stuff, right? So basically, anything you add in here does not get moved to GitHub. That's just what the ignore does. It ignores it when pushing to GitHub. So that's actually a very important security step. We are actually running out of time, so let's just continue. So we're going to go to Insurer. I'm going to verify that I'm human. Sorry, this is just taking the whole world to load. All right, so I'm going to I already have an account, so I'm just going to log in. But if you don't have an account, try to register. So I already logged into my account, right? Now from Infura, you can, if you don't have a new project yet, right, you could just simply click on create new project, choose if it's Ethereum or IPFS, add the project name, click create and stuff like that. So but I already have a project here. I already created previously, right? So and I'm just going to use a URL from one of them. So I might just head to whatever it is, Amazon, right? And as you can see, Infura provides RPC for like different networks. You can choose the network you want, right? But we are focused on Ethereum. But within Ethereum, I also focused on Sepolia. Why is Sepolia not here? What am I?
Excuse me, sir.
Yeah, I can hear you.
Please, can you slow down? I'm trying to create my Nigeria account.
Yeah, it's just that we are running out of time. But okay, just continue. Probably wherever we stop, but probably have to continue on Tuesday. It's just I was hoping we don't have a class on Tuesday. If we could round up everything we're going to do today, we'll not have a class on Tuesday to give you guys time to like concentrate on the assignment and to get started with our classes again by Sunday. But if we can't round up today, we'll just continue by Tuesday. So there's no problem. All right. So, have you set up your info yet?
Almost done, sir. Almost done.
Okay, so I'm also setting up mine. I'm seeing choose your application category. I'm seeing DeFi and NFTs. Am I choosing NFTs?
Just choose whatever you want. Nothing exactly very important. Just choose whatever you want and just set up your that. That's the main important.
Okay,
All right. So are we there yet?
yes, created.
Um,
Creating the API
create
key.
like it, right?
Okay. So just going back to where we started from, right? Oh, no register. Why is this being like this? Yep. So yeah, create new API key. Yes, that's correct. Create new API key. Then choose Web3 API and put in your API name. Then click create. Are we there?
Yes, done.
Yes, sir.
All right. So once you create, my internet is really doing me dirty. I don't want to. So, but once you create that, just go in. My internet is really messing up. Just go into the particular project you just created. For me, it's Amazon, right? Just go into it.
Okay, you said for Ethereum we have to choose Sepolia, right?
Yeah, yeah, choose Sequoia, choose Sequoia, Sequoia. Then copy your whatever it is, right? Copy this your RPC URL. Have you copied it?
Yes, sir. Copy.
All right. Then go back to your file, right, and paste here. Just paste that in here in your EMD variable.
Done.
All right. So the next thing we are going to need, right, is our private key. I believe we love all of us know how to import private keys already. So we're going to head to MetaMask. Got it. We're going to head to MetaMask. Then we are going to click on for that particular account. I believe we already have an account, right? Click here, click on account details, then click on show private key. I'm not going to show my own. I don't want you guys to steal my Ethereum. But click on show private key, and your private key will be revealed to you, right? So once you get that, whatever it is, right, just paste it in here too. Paste it in here. Have we done that?
So please come again, sir. Sorry.
So head to MetaMask. You already have MetaMask set up, right?
Yes, sir.
Head, click on the three dots by the left, as you can see. Click on account details, then click on show private key. So once you click on show private key to ask you for your password, right? Enter your password and copy your private key. Once you copy it, come back to your VS Code and paste your private key in here. Have we done that?
Yes, done.
Now, the next thing we're going to do, which is like the last but most important part, right, is getting our Etherscan API key. So to do that, the first thing you need to do is we're going to search Etherscan, Etherscan.io. So once the reason we need this, right, because we want to verify when we deploy our contracts, we want to verify it automatically through automatically too. So head over to Etherscan and click on sign in. If you don't have an account, you can't easily register.
Victor,
Are you guys saying that?
tell me some more, Victor.
Oh, sorry.
You said? No, I think mine is like 0x Darlington and password should be like not like I can remember, but let me try. Then there's I'm not a robot login. Yep, that's it. So I already have an account created, right? So as you can see, I just logged into it. So once you've logged in, if you've not created your own account, the registration process, sometimes the verification process takes a long while. Might not be really able to wait. So but just head to API keys when you do that and copy your API key. You can create an API key if you've not created previously, but once you've created it, you can now copy it and use it, right? So, but for I will just paste my own API key, right? Try to simply have verification in here. Although only 5 calls are permitted per second, but I'm sure we could use that. So I'm just going to paste it in the chat, right? Just to save our time. So I think for people that are following, right, I think that's some Tochiko and Victor. Just use my API key instead.
Sorry, why should we use your API key?
Yeah. So why should you?
Why should we use your own API key?
So the reason why I said you use my own API key is because like you would have to like I assume you've not created an Etherscan account previously. And so if you've not created an Etherscan account previously, you probably need to like start registering, getting verification code, and like you
Um,
as you can you don't have a lot of time.
no, one of
Or do you
the
have
I've created already and I have mine.
oh,
we have,
okay, okay. All right, if you have one then just use yours.
yeah, we have it. Yeah.
All right. Then have you copied the API key then?
Mine, yes, I
Yes.
copied
Yeah.
mine.
All right. So if you copy this, just it's paste the API key here. So do we have the three variables filled in now? Do we have the three variables filled in now?
Yes, sir.
Yes.
All right. So I'm just going to get. I'm just going to delete this file, right? And I'm going to copy the one I've probably done. And let's see, somewhere from here. Um. Um. I'm finding it here. Minutes. So I'm just going to copy this and go back in here. NFT maintain class. I'm just going to paste this here. Right. And I'm going to rename this file to .env. Okay. All right. So having done all this, right, we will now head into our header.config.js. And the first thing we'll probably need to do, right, is we're going to need to import our .env package. And going to use the config variable or method. Then we're also going to need a tool, which I have we installed this here? No, we're going to need a dependency called hardart deploy. So we're going to install that. While that is installing, I'm just going to walk us through what hardart deploy is and why it's important, right? So hardart deploy basically I think was created by Week Howard or something, and it's basically think of it as a framework or whatever it is, a library that helps you manage deployments better, right? So normally if you're using hardart hardart deployments method or whatever by default, right? There are some things you can't do. For example, you can't manage deployment very effectively. Some advantages that Hardart Deploy provides to you, right, is the ability to like create named accounts, the ability to like for example, if you've deployed an account previously, a contract previously, it saves those details, right? And when you probably run npx deploy again, it will just use the details for that previous contract you've deployed, right? So that starts the whole deployment from scratch and the various other advantages it provides. So most times when you're working on company related projects or big projects, right, you're contributing to open source. I think that's like one of the most popular libraries used to manage deployments correctly. So it's something I urge you to check out. I think it's called Hardart Deploy. So I'm just going to paste the link in the chat, right? And you could probably read up on it, go through it, read up on it, play around. We definitely there's a lot of things here we can cover. It helps you with proxies, it helps you with a whole lot of things. So we can't cover a lot of things here. So but do check it out. I'm just going to paste it in the chat. Right, so I just pasted it in chat, right? You could probably check it out, and maybe make reference to it later. So we are going to require. Have we installed it? Let's see if it has installed. Right, did I install it? Yeah, it has installed. Right, so we're going to require that to add that deploy. All right. Now within here, we are going to start with specifying our default network. So in case we want to like deploy or test on Hardart local host, right? So we'll just specify this to be Hardart. Okay. Then we are going to specify our networks. Currently we just have Sepulia. So we're going to be using Sepulia. And within Sepolia, we want to specify first for our URL. So our URL is going to be okay. We're going to need to import. So I already have those things in my .env, right? So which I believe you already have to. You're following the class, right? So we're just going to do this. So we're going to import the Sepolia RPC, and we are going to get that from process. This is how you access environmental variables, right? Using .env Sepolia RPC. Then we are going to get the private key. You can get the private key by doing process.env private key. Then you can also get the Etherscan API key. Let's get that too. Our Etherscan API key. We're going to get that by doing process.env.etherscan API key. All right, so having gotten those three variables, because we're going to be using them within this particular file, right? Our URL is going to be obviously our RPC URL is a poly RPC, right? Then we are going to need to specify our accounts, right? And for our accounts, we just have a single account we want to deploy from, which is the private key. We're going to pass that in. Then what else do we need to pass in? Our chain ID. We need to pass in our chain ID. So let's get the chain ID for Sepuli. I don't think I have that by heart. So I'm just going to let's go here and chain ID for Sepolia. This is the chain ID for Sepolia. I'm going to pass that in. And finally, we're going to pass in what I call block confirmations. This is going to be very important for verification, right? Because to verify a contract on Etherscan, the contract has to be first of all available. So we want to make sure that the block has been finalized before we go ahead to start requesting for verification. And so to do that, we're going to wait for a number of confirmations, right? So we're going to wait for 6 block confirmations before we call our verifiers, our verify scripts. All right. So having done that, I believe we are done with our networks, our network configuration, right? So we are also going to configure our Etherscan. We're going to configure for our Etherscan. Not inside here, sorry. Inside here rather. We're going to configure for our Etherscan, right? And the only thing we want to configure here is the API key. We want to just pass in the API key, which is Etherscan API key, right? So this is what we're going to use for automatic Etherscan verification. Then finally, this is something that is used by Hadas deploy. We're going to need to pass in our named reset the config for our named account, right? And what we want to set is just the deployer. So we want to say for default, right? That's for default network. We want to use the 0 account. So in our array, remember the first element of an array is always has an index of 0, right? So the private key is when we see 0, basically we're referring to the first element in the array, which is just this particular account. And for chain ID, this chain ID, right? We also want to use the default of 0. That's we want to use this account, the 0 account for deployer. All right, that's for our hardhat.config.js. The next thing we are going to work on is we're going to work on our utils, our verifier utils. So we're going to create a new folder and we're going to call this folder utils, right? And in here, we're going to create a new file, which we're going to call verify.js, right? Now, this new file, this verify.js is going to basically handle everything as regards to verification of our smart contracts, right? So we're going to write a little script for handling verification of our smart contract. I don't know if we are following. Am I too fast?
I'm feeling, but please, can I see the previous code?
Can you see it?
The previous code he had at config.js.
All right. So
Yeah,
the
please explain the this configuration again, please.
All right. So first of all, we started with importing some important things we are going to be using, right? Some important dependencies. So first of all, we import the .env we call the config method. So we're going to use this for like getting our variables from our env variable, right? The next up, we import the hard hat deploy because we're going to be needing this. I think from this is where we have this made available, right? So we need to import the hard hat deploy dependency. Then the next thing we went ahead to do, right, is set our constants. Remember those things we set in our env variable in our those are our environmental variables, right? We set in .env. We first of all import the Sepolia RPC. We import the private key. We import the Tascan API key. Someone has a question for the chat. Okay. And so we import the Sepolia RPC, the private key, and the Tascan API key. Now, having done that, right, within our module.export, we start with specifying, of course, the Solidity compiler verification, obviously, which is 0.8.19. Now, because within our Solidity contract, we said any compiler greater than 0.8.0 should work, right? So automatically, this should also work. Then our default network is Hadat. Now, we're not going to be using default had that local network, right? Local host within today, right? But basically, if you want to test things locally without having to, like, let's say, use an internet connection or go through the process of deploying to a testnet, which is usually slow, then Hadat has like a local development environment you can actually spin up. You can spin up, I think I do that using npx Hadat node, and you'd have access to like a default you can actually use to like carry out tests and stuff. So the next thing we go ahead to do, right, is by the yes, something you have a question.
Yeah, about that local environment, right? I know I
Yeah.
can like spin up that local environment, but I don't know like how to interact with it, just like we interact with our contract with Etherscan, testnet.
We actually don't have time to go through that, but you know what? You could ask me this question again in probably in the group chat, and I would recommend resources for you. Or if not, we could find a way to squeeze it into one of our classes. That works, right?
Yeah, thanks.
Yeah. So let's just run. Then within the networks, the networks, right? We specify the network we have Sepolia. So you could specify multiple networks here. So if I want to use Goeli too, I could specify Goeli. I could specify. I could specify if I have want to deploy a minute, so I could also specify minute here, and so on and so forth. Right, but for the class, we are just going to be using Sepolia. So the things you need to pass in, obviously, you need to pass in the RPC URL. That's the URL that you want to call, right? Each time you want to make the get or post calls, right? You need to do that to this Sepolia RPC. Then we specify the accounts that had that need to interact with, right, for deployment. Because if you're deploying on testnet or mainnet, you obviously need to pay for gas fees. You need to do that from an account. So we do that by specifying the private key, which we got from our MetaMask account, right? Then we go ahead to specify our chain ID. So the chain ID is like a unique ID that you can use to identify the particular chain you want to interact with. And for Sepolia, it is 11155 So that's the chain ID you want to interact with. And I said the block confirmation is very important for verification, right? So well, before we verify our contract, we want to ensure that
So,
the block.
hello, sorry for interrupting you, sir.
Okay.
Sorry for interrupting you. The chain ID, is it compulsory or optional? I think we should know those things that are necessary and those things that are optional. Thanks.
Yeah, yes. Amongst everything here, right, the only optional thing, in my opinion, is the block confirmation. You need to pass in your chain ID. How that needs to know the chain ID, the chain you want to deploy to, right? The block confirmation is the only thing I could say is optional. That's what I'm trying to explain here. So I added this, right, because I want to write a verify script we could use to automatically verify our contract. And this particular block confirmation says that before we call our verify script, we want to wait for a block confirmation of six. That's we want to wait for six block confirmations to ensure that the block which our contract was deployed in, right, is finalized before we try to verify the contract. Because if you try to verify the contract of and verify an existing contract, you're going to get that error. So that's why we need this particular argument. Then the ETAS card, like I said earlier, is very important for the verification. Obviously, you need to pass in your API key, which they can be used for the verification you want to do, right? Then the named accounts is like it's from hard deploy, right? Which we can use to specify the account we want to deploy from. All right. So next up, we're going to write our verify.js script. Now we're going to start with importing the run module from Hadat. So we're going to do that from Hadat. Okay. And once we do that, we are going to write our verify function. So this is going to be an ASIC function. It's going to take three important arguments. So we're going to pass into it a contract address. It's going to take our constructor arguments, and it's going to take like the contract we want to verify. All right. So when we do this right, we are going to, the first thing we want to do is for good user experience, we want to console log verifying contract. So let's just console log verifying contract. So user we know that in the process running currently is like contract verification. And once we do that, we are going to use a try catch. In case there are any errors, we can catch that and console log it, right? So we're going to await running this method. And the particular task you want to run, right, is called verify. So verify. So this is the task we want to run from Hadat. And this task is going to take some arguments. It's going to take an address argument, which is going to be the contract address, right? Then it's going to take constructor arguments, which is going to be args. And finally, it's going to take the contract you want to verify, right? These are the three arguments it takes. And once it takes this right, um, the run automatically is going to run the verify. So this verify is called the hard hat tags. You could go to the hard hat documentation to read more about it. That's what tags are like. Think of them as probably when you write what are they called? You could add scripts to your package of JSON to run specific commands, right? Tags are just something similar. So you call them and they carry out some particular functions or some particular functionalities, right? So this verify task is used to like verify your smart contracts basically. Yep, so after you try, right, which we just completed, the next thing we want to do is we want to catch any error. So we want to see catch in case we have any error, right? What do we want to do? We want to do two things. First of all, it might be we got an error because we are trying to verify an already verified smart contract. Now, when we try to verify an already verified smart contract, you're obviously going to run into errors. So we're going to try to check for that use case. So to do that, we're going to say if the error message, right, which you can get from error.message. I don't think I expect to explain all this since I believe we already have a, if not a very good, but like a proper JavaScript fundamental knowledge. So error.message, right? We want to convert the messages to lowercase because we're going to do some comparisons. And if the error.message dot lowercase, right, if it includes, if it like includes this letters already or this phrase already verified, right? So if the error message includes this phrase already verified, they want to just simplify the error message for the user and say, okay, let's console or log contract has already been verified. Contract has already been verified. But in a case it doesn't, right, and it's probably a new error, right? We just want to say else. Just tell the error to the user. He should find a way to debug it himself. He should not stress us. Just show the error to him. Yep, so explain this again, right? We start with specifying our verify function is an async function, obviously. So we pass in the three arguments: contract address, the argument, and the contract. We start with console logging, verifying contracts, and we start with a try, catch, start with a try, right? Don't see how it's run the verified task, you pass in the argument you want to pass in. If there are any errors, catch the error. If the error in small case or in lower case, right, includes already verified, just console log contract has already been verified. If not, throw the error. Now the final thing we want to do, right, because we want to make this particular function available to like different other files, we're going to export it. So we're going to say model.export is equals to, let's just pass in verify to export this particular function. Let's check, are there questions? I didn't get the block confirmation. Just okay, I'm going to repeat it one more time. So the block confirmation, like I said, is necessary. Okay, I'm going to explain this now when we run the deployment script. So you're going to see the block confirmation in actions. So but let's just go ahead to write now deployment scripts. We are already out of time. So, but if you have any more questions as regards to this, I'm sure the record is obviously going to be available. So watch it. If you don't understand anything, then ask questions on the group chat and we'll definitely attend to you. Times 912. Right. So next thing we want to do, right, is we're going to create a new folder. So this new folder, we're going to call this folder deploy. Right. And within deploy, we want to pass in, we want to call our function deploy nft.so.js, sorry, the JavaScript script, the script basically. So it's called .js. All right. So in here now, we're going to write the script that is going to handle all our deployment and verification processes. So these are our Achilles heel. So the first thing we're going to do is we're going to start with importing the network variable. We're going to do that from hardhat. So this is going to require hardhat. All right. Then the next thing we want to do, right, is we want to import our verify function. Our verify function, we can find it in, if we go out, we're going to check utils. And you're obviously going to find it inside the verify.js. Okay. And finally, we're going to require, what's it called? We're going to require .env config. Okay. Just like doing this in my inputs. This is such a horrible language. Right, so the next thing we'll probably want to do is we're going to, because this function is going to be exported, so we could just do this from here, right? And we could see module.export is equal to async. It's going to be an async function. And from hardhat to deploy, right, we are supposed to pass in two arguments. We're going to pass in the get named accounts. And we're going to pass in deployments. Okay. And an async function, arrow function, and we want to get, the first thing we want to get right is our deployer. We're going to need him. And we can do that for calling the get name function account method. So call the get name account method and it will return the deployer. Remember the deployer we specified in our hardhat.config, right? For our chain ID of 11550 is going to be 0. But if you saw the default, that's what the local host is going to be 0. It's still going to be 0 too. So the next thing we want to do, right, is we want to get our deploy function. So our deploy method, rather, this is what we're going to use deploy our contract. And you can get that from deployments. That's this deployment variable, basically. Okay. Having done all this, it's time to deploy. Let's deploy our contracts. Now we're going to write, we want to store this in, we want to get the contract that is deployed, right? Because when you call the deploy method, it returns the contract as deployed, right, or the contract factory, whatever it is, right? So we're going to pass in our contract. So obviously we're calling the deploy method. And the first thing we want to pass in is our contract, our particular contract we want to deploy. So if you check our contract name, right, you'll see our contract name is badass dev. Now we want to pass in the factory, you can check it in artifacts. So if you check artifact, check contract, you see we have a badass dev.json, badass dev.dpg.json, whatever it is, right? So those things are what Hardhat uses. So what you just need to do is tell the Hardhat the particular contract you want to deploy. So for us, it's badass dev. Just copy this. It's not running into for funny errors from typos. All right, badass dev. And badass dev is going to take in some arguments, obviously. So first of all, we want to specify the account we want to deploy from. We want to deploy from deployer. We want to specify the constructor arguments. Now, if you check our NFC contract, right, we say we don't take in any constructor arguments. Just that we just passing this by default. Another thing we could probably have done is supply name and symbol into here and just pass that in here. But we want to pass it in by default, right? So our constructor argument is left empty. All right. So in our argument, we just leave this empty and we'll move on. Now I want to log. So these are some of these things you would probably not understand until you go through this document to try share. So please go through this GitHub repo when you can. Okay, so the log basically tells basically how that or the console or terminal to log different values. Like for example, when you're deploying, it show you deploying to these to show you the deployment address, whatever it is, right? So it's this log that is responsible for that. Then finally, this is where we are going to use our confirmation. So it also takes in a wait confirmation argument, right? And we want to pass in our network dots. So you can assess your config parameters, right? Like for this now, for example, with network config parameters by doing network.config dots. What particular parameter do we want to get? The block confirmations. So we'll just copy this. And we want to get network.config.block confirmations. All right, so having done all this right, this is going to deploy our NFT contract. This is going to deploy our NFT contract. Now, the last thing we want to do is we want to verify our contract. So verify our contract. And to verify our contracts, right, there are certain things you want to check for because you want to prevent as much as possible. You want to handle every use case as a developer, every possible scenario, right? So the first is we know that we can verify. I'm not sure we can verify contracts or local host that's had that node, right? So we want to ensure that for us to start our verification process, our chain ID is not equal to 31337, which is like the chain ID for your default local host, local nodes, right? And you want to also check that our Etherscan API key, which is set in .env, is actually set. So to do that, right, we are just simply going to say ensure that chain ID. We can get chain ID from network.config.chain ID. We want to check that this is not equal to 31337, which is the chain ID for your local node. And we want to also check that process.env. Let's just set that up somewhere. So just to make this look better, you could say constant Etherscan API key is equal to process.env.Etherscan API key. Right. Now I want to check that this exists. So it's like common JavaScript. So if you do this right, it checks that this exists. If not, it throws an error. And then we are going to do our verification. If like all these conditions are satisfied, that's network.config.chain ID is not equal to 31337 and our Etherscan API key exists, then we are going to go ahead to do our verification. If not, it's going to skip the whole verification process. But I think there's a question, so let's attend to that before we proceed. Please, can someone copy these links to the group chat? Okay, I think CC is already doing that. I don't know if he's still in the call. Yes, this is in the call. I think he's doing that. All right, so within within this if statement, right, we want to now do our verification today. So
Please, sir, where is the 313?
Sorry?
Why is the network.config.chain ID? Where is the 31337 coming from?
Okay, I said the 31337 is the default chain ID for Hardart local node.
Oh,
If you call
oh,
the
oh, okay.
chain ID for Hardart node, you can see here is 31337, right? So we are checking that this chain ID is not what is returned when we call network.config.chain. That's just a way you can check that, okay, the network is actually a testnet, that is a sepal layer and it's not localhost. I don't know if you understand.
I guess I've gotten it.
Yeah, Ezekiel, do you understand? All right.
Yes, I've
So
gotten it. I've gotten it.
right, so our contract, our NFT contract, sorry, our verify function, right? If you check it, it takes in three arguments. It takes in the contract address, the constructor argument, and the contract. So we're going to specify our contract address, basically, which we can access the factory that's returned, right? If you call the address a method on it, right? It returns the address of this particular NFT contract, right? And for arguments, we're going to just leave that empty. We don't have any arguments. And for our contract, this is how you specify your contract in Haddad. So you're going to specify like we're going to our contract is in contracts so right? So we're going to pass that in. We're going to say contracts, right? Slash badass dev dot so that's the name of the file. Then we're going to use this column and we're going to pass in the contract name, which is badass dev. So we're going to pass in this. That's the particular contract we want to deploy because it's possible for a single Solidity file to have multiple contracts. So you need to pass in the particular contract you want to deploy, which is badass dev. All right. Now, having done this, we are done with our verification contract, our verification scripts. Now, is that not amazing? Finally, we're just going to do a little thing here. I'm going to export some tags. I'm going to say module.export export some tags all and NFT. So this is just tags are important, right? For example, if you want to like call the deploy script on just a particular script, right? You can use tags to do that. You can use tags basically to differentiate different scripts. Now, having done all this, right, we've written our verify.js, we've completed out harder.config.js. Now let's try to deploy our NFT contract and let's see if this deploys. So we're going to go to our terminal. I'm just going to clear this, right? And I'm going to run npx harder deploy. So this takes in a particular network parameter, right? You need to specify the network we want to deploy to, and I'm going to specify Sepulia. Now let's run deploy and let's see what happens. If I start to compiling, then it starts deploying badass dev. That's our NFT contract. All right, that's a deploy transaction. So we're waiting for this transaction to be completed. Does someone have a question? I love Ubuntu. Okay, well, Ubuntu is cool. Evidently, there's no Windows.
Hello, sir.
Hello, sir.
Yeah, I can hear you.
So please, can we see the deploy script?
Please, can we see the deploy script?
Deploy script, okay. This
All right,
is
sir. Thank you, sir.
yeah. So as you can see, this thing has been deployed. and you can see the address it was deployed to and the number of gas it was deployed. Now you saw the wait, right, that happened between deploying the contract and verifying the contract. That's where the block confirmations come in. So we deploy the contract, we wait for 6 blocks to ensure that the block which contains the contract, our smart contract, right, was finalized. So there's what is called finality. So you want to ensure that the block which is finality, right, like the block is finalized before you go ahead to like call the verification. Now once the block is finalized, right, you're sure that the contract exists on the blockchain. Now that's what we do, right? Having done that, you now see that it calls verifying contract and console the logs verifying contracts, right? And then it says successfully submitted source code for contract. You can see where it's submitted for verification in Block Explorer. Now let's go to the Block Explorer and let's check out our contract. All right, so we're just going to go here, paste this, and okay. So as you can see, these are our contract codes. As you can see different files you did not even use. Just these things were imported from Open Zeppelin. So by the reason of inheriting the ER721 we inherited and the URL storage, you can see we inherited 17 different other contracts. Now we're going to go to, if you go to our read contract, you can see the different read methods you can call. Forgive my network, but you will see different read contracts you can call.
Excuse me,
And if you go to write call, oh, network, please.
sir, excuse me, please.
Yeah, yeah.
Can I see your verify script, please?
Can you see my words?
Verify script.
Sorry, I didn't hear you. Can you see my words?
Can I see your verify script?
Okay, my verify script. Okay.
Okay, thanks.
Yeah. So did everybody succeed in deploying the person's own NFT contracts, or did you run into errors?
I ran into an error in that like
I ran into errors.
All right. So what error did you run into?
Okay, I'm seeing there is one or more errors in your config file. Invalid value undefined for hard.config.networks.sequoia.url. Expected a value of type string.
Right. Like within, I guess, did you import the config at the ending, like the config method?
Yeah, I did.
Did I believe there's something actually missing, but because of time, we will probably not be able to like debug this personally. But okay, all right. You know what? Every error you had, just paste it in the group chat, and we're going to debug it after the call. Any like if you can still be around after the call, probably after all that's leave, we could just debug it together. But for the meantime, let's just complete the class. That's okay now, right?
Okay.
So having deployed our script, right? If you see if you call the name is badass dev, the symbol, BDD, and so on. Now we are going into like the second part of our class, right? Now I'm wondering if we should just do this on Tuesday instead, because I wanted to take us through IPFS, setting up your own IPFS node using Pinata, writing your metadata, and probably like publishing your metadata and stuff. So, but also I noticed a lot of us had not started attempting the assignments yet. So the initial plan I had was if we could complete 2 classes, that's this class and Tuesday class in today's class, right? Then Tuesday will be lecture free and you can just take out your time to complete the assignment because assignment submission is on Wednesday and it's really not changing. So what do you guys think? Do we take out extra 30 minutes to complete like our NFT contract today, or should we move it to the next class?
yeah, I think we should take more
Yes,
attention.
sir. Today.
Let's complete it today.
All right. Um, I think there are more persons saying today, and there's just people saying next class. Well, if you stayed up to this point, I think you've tried. So if you want to leave, there's no problem. The recording is still going to be made available. But then I think I also stand with let's just complete it today so that we wouldn't have lectures on Tuesday and you have time to like do your assignments. Okay, so now the next thing we're going to move into is we're going to move into IPFS, Pinata, and stuff. Um, all right, so the whole concept of decentralization, right, is to ensure that you don't still stand up one day and one person who you don't know just removes your file from the system. So what do you, it's a thought that of course the whole decentralized ecosystem is not complete without like a decentralized file storage system. So for example, for those who've done a lot of Web2 development, when you want to deploy when you want to host the website, right? There are always there's always a specific image folder where you put your images, and these images are definitely hosted online, right? And of course, they can be deleted at any time. That's if you decide to delete it or something like that, right? So, but the whole idea basically is also within Web3, also we can also have we need a decentralized system to like store files, right? Store images and other stuffs. So the question is, how can we like do that, right? Now, this is a problem that IPFS tries to solve. So IPFS stands for Interplanetary File System. IPFS. IPFS though, yeah, your tech, because tech. So IPFS is simply like a file sharing peer-to-peer network. So just like you have the decentralized internet, like you have Ethereum, people can spin up nodes and they can people can spin up nodes and probably store information, store everything from the Genesis block and make this information available to you, like right. So there are peers, people who partake in IPFS nodes that partake in the IPFS system, the centralized system are called peers. Now these peers are responsible for storing files, right? And obviously you can use SD keys like Pinata. Pinata is an SD key which we're going to also use, right? But before then, I want to like help us understand what IPFS is, right? And we're also going to spin up our own IPFS node. I've done that and it's also very easy. So we are also going to do that, right? Although we cannot go through the installation process because of time, but it's not very difficult to do, right? So like I said, IPFS is people who partake in the decentralized storage system are called peers, and there are different. If you join the system at the point, you see different peers, right? So these people are there are people just like we have people who run full nodes and they do this from like constantly and try to ensure that their systems are always up and running. There are also people who run full nodes in IPFS and their nodes can always keep running. You can also spin up your own node, right, which is also very advisable because when you store files like on other people's nodes, right, there's a tendency they can decide to delete it. Obviously you can decide to pay for block space. I think there's this way to like do that where you can pay for file storage space, right? And it's a whole lot of study on its own. I think I once wrote a little introduction to IPFS on my LinkedIn, and it's actually very, very, very useful stuff. You could actually go through it if you are looking to understand IPFS. The problem is if my um okay. Can I find that post? CKP. Yes, this should be it. Yeah. So it was basically LinkedIn PDF document, right? That goes about over IPFS, right? And as you can see, IPFS is an acronym for Interplanetary File System. You can see different things, right? how IPFS works. Of course, this is something we need to talk about, right? So you probably wondered how file location stored, right? Because we have what we call a CID, which you can use to like locate files on IPFS. So how do you think that works, right? So unlike traditional web URLs, like traditional web universal resource locators, right? That contains paths to like a particular file location. IPFS locates files by content. So this is how it works. So unlike probably if I want to find a file or I wanted to link, as you can see, we did it in our deploy NFT.js, right? When I want to link to a particular file, I have to specify the path to that file. But in IPFS, the URL of that file you want to like specify is done by hashing using a unique hashing algorithm, right? Hashing the whole content of that particular file. That's what forms what we call a content ID. That's a CID. Now, so as you can see, you usually have something like QM, right? This is like a unique content ID for what you find within blockchainforbabies.com/about. Now, if you go in, right, you can, we don't have time to go through this, right? But that's something I just wanted us to know. So that's how you come up with CIDs, right? I'm just going to paste this resource. I'm going to paste it online, and you could in the charts. You could probably go through it later. And of course, you could also connect on LinkedIn. So I don't use it a lot these days. Uh, Okay, so yeah, so going forward, right? Let's try to spin up our own IPFS node and let's see how that is done basically. So let's have the IPFS app. So let's just open the IPFS desktop. This is really resource heavy and it doesn't make my Mac start hanging because I haven't shut down in a long time. Probably going to take a long while to load up. Yeah, so but while that loads up, right, another tool we are going to be using, we're going to be using within the process, right? I don't think it started. It did no. Okay, it did starting up. Yeah, so could not connect to the IPFS API. Why? All right, it's connected now. So as you can see, this is like my own IPFS node. As you can see currently, there are only 28 peers, nearby peers who are like discovered. You can see there are 38 peers currently, and it changes as more people join, more peers are added, more people leave, more peers are removed. So this is my own peer ID. So currently there are 44 peers, and this is like the user interface. You can see the bandwidth over time. Now within files is where like the whole file storage comes, right? That should be within files. So if you come to files, you can find the whole file storage. So I don't even think I told us that, right? You can actually store websites, like full websites on IPFS. If you want your website to be totally decentralized, right? You don't want to have anything to do with like the normal web. You don't want to have anything to do with like the internet, right? You want everything to be totally decentralized. You can actually store your website on IPFS. And for example, let's try to like open this my website. So let's share the link. I'm going to copy this and we're going to try to open it. Um, so if you paste this right, sorry, give me a minute.
More link many for today class.
Guy, you don't tell what they tell you about this on my gaffer now.
Like, guy, the mic is something else.
The mic they enter inside my ear.
No, be just my ear. The entire inside my head.
Sure, no, say this call they recorded.
Yeah, is this still from your phone? Like, what is that one back there again? Ezekiel, is that from your phone?
Don't ask him before you go talk to later.
No, no, no. It's the earpiece I'm using. Don't worry. The earpiece I'm using.
That they give me that sound.
All right, guys. Sorry about that. My network got kicked me out again. Just trying to fix it. And but can you guys hear me now?
Yes, sir.
Yes, we
Can
can
hear
hear
you
you.
now.
Yes, correct.
We can hear
All
you.
right. All right. So I was going through IPFS. Right. Let's just close this. Now I said you can store a full website online, which I once did. Right. But you should note that the disadvantage of doing this, though, that storing this on your local node is, if you store this on your local node, right, you need to make sure that your node is running 247 for, or less, if like I shut down my node, right, people would be unable to, like, for example, access my website or access my images. This is taking time to load. I have no idea why. Still started. Yes, start. My PFS node is running. um Right, so but while that is taking the whole world to load, right, let's take a look at Pinata, because Pinata is what we're going to be mostly using, right? You don't need to run your own node. It's not necessary. But if you want, it's something fun you could try out. That was the whole essence of showing you that okay, it's possible. You could run your own node and store your own stuff and all right. So now, but Pinata is what we're going to be using. So Pinata, think of Pinata as like an SDK for IPFS. So it makes it very easy to upload content to IPFS. And there are developers tools that also make your usage of IPFS like pleasant and interesting. And we are going to be storing our metadata and everything right to Pinata. But before then, we are going to be creating some. I'm going to create a folder within our minting class, right? I'm going to call this new folder metadata. Okay. And within metadata, I want to, first of all, we're going to, the first metadata we probably need is an image. So what image will be suiting? I don't know why this is still not loading. Let's just forget about that for now, probably. Okay, yeah, the gateway is taking too long to fetch your content. This could be due to several reasons. The CID does not contain the host that contains has gone offline. Yeah, it has gone offline, but like, I want to assume it's because my node is running on a very slow network. That could be the only possible explanation. But I'm still online, right? I'm not offline, but I'm probably on a very slow network connection. So maybe the next time you guys would have me again, I could still like spin up this IPFS and show us how it works. Now, if you head over to Pinata, like I said, I needed an image. I was thinking if there are any cool images, like are there any cool images now that developer related? But whatever, we don't have a lot of time to be doing this, right? So I'm just going to use blockchain UNN logo. I think I have it somewhere. Um, I have blockchain UNN logo somewhere. Yep, yep. So we're just going to use this. This is going to be the first thing, our logo or our image for our NFT. Then we're going to create a new file. This new file, we're going to call it metadata.json. Oh, sorry. I want us to create it within our metadata folder. Let's create this new file. We're going to call it metadata.json. And inside here, we're going to be specifying different traits and characteristics for our particular NFT. So because of time, I've done this previously, so I'm just going to copy the contents for one I've previously done, right? And we're going to start with that. So where would I find that again? Do I have it here? Yes. Let's just copy the content for that particular metadata and use it. Metadata. Where are you? Yeah. So I'm just going to copy this. This is this. Right. So first of all, we need an attribute. We need the attributes. So our trait type. Um, let's just call it developer. I don't know. Developer. Value badass. Trait type. Um,
Excuse me, sir.
let's see. Yeah, yeah, yeah.
Can you paste
Okay.
this metadata configuration in the chat, please?
In the chat.
Yes.
All right. Yeah, I'll do that. I'll do that. Developer. Let's call this blockchain UNN badass developer. All right. And we are going to paste our IP link to our IPFS content in here. The name is going to be um that's what we're going to do now. So I'm going to try to log in. So okay, I think I've done that already. Yeah. So we're going to the first thing we're going to be uploading, right, is our image. So we're going to hello, can you guys hear me? Can you guys hear me now?
Yeah,
We can hear you.
it's just that it's
Yes,
slow.
I can hear you.
Yes, yes, I can hear you.
Where did you guys lose me?
I think we lost you briefly. Are you still on the call?
Yeah, yeah, still on call, still on call.
I can hear you from my end.
I can also hear you.
All right, so asking where did you guys lose me?
At the metadata, the JSON metadata.
Yeah, so I'm going to paste it in the chat right now, and you can just copy this attribute, right, and add it to your own metadata. So within the metadata.json, I just pasted all those, right. So the first thing we want to do is upload our image to Pinata. So I'm going to head to Pinata. I'm going to click on add files. I'm going to click on file, and I'm just going to drag and drop because of time. So if you go in here, we are in the same class, metadata. I'm going to drag this guy. Come here, and
Excuse
then
me, sir. Is Pinata an alternative to
I'm going to
Firebase?
drop you. All right, and I'm going to upload. Yeah. I think they do similar thing, right? It's just I think Pinata is way more popular in my opinion. I think they do the same thing. So it's going to take a while, right? But this is going to get uploaded, and once this gets uploaded, we can move on from there. So So we could just create your own Pinata account and try to upload your own metadata, your image. You can use whatever image you want to use, right? It's taking more time than expected, probably because of my network. Yeah, so finally it has been uploaded. So where are you? Where are you? Where are you? Let me reload. MTN, I would never forgive you because of this. Oh my god.
Like this is what I face every Sunday in greenhouse.
Oh, you still have greenhouse. Oh my god. This is really network is so horrible today, honestly. Like really, really horrible. I hope I'm still even on the call. Okay. I am.
Question.
You have a question?
Yes, sir.
You have a question? Alright, ask a question.
Okay, sir, when we say Pinata, are we still making use of IPFS?
Yeah. Pinata makes use of IPFS. It's just an SDK, like what SDK does, right? It just simplifies your use of Pinata, your use of IPFS. So automatically you have access to like a 24/7 running PA, right? And you can just upload the file to a Pinata PA, right? And your file is like saved and always ready for you, something like that. So it's just an IPFS SDK.
Sir.
Yeah, finally this happened. This finally worked. So sorry about this, right? The network has been really terrible. So within the image section, right? If you check what I copied and pasted for you, I had already done that previously. So if you check it, you would find out that there's already okay. There's I've already removed it, right? So after the IPFS and the dash dash, right? I want you to now paste this for those who have probably not uploaded yet, probably because network is not
Sir,
paste
please,
this. You could use this after the IPFS network, please now. You said?
I'm trying to create my Pinata account. I'm almost done, please.
Yeah, don't worry. You can just move at your pace, right? So we have to run now because we are way out of time, and yeah, but like after you create your Pinata accounts, just upload it. Run into issues, we could you could call my attention back and try to resolve it together. Right. So, having done that, right, we now have our metadata JSON completed. We are also going to upload this to Pinata. Now, we're going to head to Pinata once again, right? Click on Add Files, File, and we're going to upload our
I have a
metadata
question.
JSON. Yeah. Yeah. Please ask a question.
Okay, the
Yeah,
link that you
Chidrim, you
just
can ask a
posted,
question.
is it for the yes?
I can't hear you.
I said the link that you posted,
I can't hear you. I can't hear you.
the link that you posted in the chat,
Mm-hmm.
what that's the last link.
Yeah, what happened
Is it
again?
for the pinata? Did you get? I said the link that you just posted, the last link you just posted in the chat. Is it for the pinata?
Yeah, yeah. This is not. It's not a link. Basically, it's like yeah, yeah, yeah. For the IPFS, the
Hello?
image is the location of the image IPFS. So you
I
need to
said there
post
was a
the
link that you
location
just
of
posted
the
in the chat,
image. This is the location to the.
like the last link. Yeah, I want to know whether it's for the pinata. Am I? Huh?
Like I said, it is for the. It is the link, as in the content ID for the image. So this is the location of the image on IPFS on Pinata.
Hello, sorry, I thought we were supposed to copy the location of our rather than using yours.
Yeah, yeah, yeah. I said you can copy the location, but in case you have slow internet like mine, you can use mine.
Okay, no problem.
Why is this trying invalid? Oh, it is actually invalid. Pinata dot cloud slash IPFS slash. Yep. So like if you did everything correctly, right? If you try to load this in the browser, you should get your attributes printed just like I have mine printed, right? You can access it from that's paste your content ID after this URL I was send in the chat, right? Just paste your content ID after that and like add your content ID after the IPFS slash and you should have access to like you should see your metadata printed out the way this is. Now we have everything we need to create or mint our first NFT. So once again, I'm going to copy this my token URI, right? And then I'm going to head back to Etherscan. So I'm going to head back to Etherscan. Not here, Etherscan, but as dev. I'm going to go to write contract and I'm going to connect my wallet, MetaMask. Um, it's probably going to take the whole world to load up. All right. So I've connected my wallet. Now I'm going to go to Mint. My recipient is going to be my recipient is going to be my wallet. My recipient should be my wallet. Now for my token URI, it's going to be IPFS colon slash slash, and I'm going to put my content ID. My content ID can be gotten for Pinata. So it's my content ID for metadata.json, right? So I'm going to copy it. After copying it, I'm going to go back to my Etherscan and I'm going to paste this. Now I'm going to write this. I'm going to try to mint in an NFT. Okay. So it turns out it says network is busy, gas prices are high, and estimate are less accurate. That's fine. Just confirm. Let's see how long that will take. So if we have this is still pending, right? Still pending. We have to wait for it to mint. Now it has minted, right? Our NFT has minted. Now the next thing we are going to do, right, is we want to check our NFT on MetaMask because we can't go. The process of listing on OpenSea is not something we can do as OpenSea doesn't currently support Sepolia, and we're not rich enough to add it to mint on minutes, right? So I'm just going to go to NFTs and I'm going to try to import it into my wallet. Now to import an NFT into your wallet, the first thing you need is the NFT address. So I'm going to copy the NFT address. I'm going to copy the NFT address, which import NFT address is this. My token ID is going to be obviously one because this is the first blockchain UNN badass dev NFT I'm minting, right? I'm going to click on import. So we're going to wait. It's going to take a while, but if everything is done correctly, we'll see our blockchain UNN NFT successfully added. So as you can see here, let's go to the expanded view. We have our blockchain UNN badass dev NFT, which has been added to our wallet. So if you can click on it, you can see it here. You can see the contract address on which you can check out the trade and stuff. You can send it to someone and so on and so forth. I don't know if we followed up to this point. Did we follow up to this point?
Yes, sir.
Yes, we are filling up.
All right. So
Though my codes,
yeah. So
I'm actually working.
so
For me, I
for
got lost
staying
at
up
the
to this
point.
point, right? I'm going to. All right. So before I answer Ezekiel's question, right, just head over to this this Sepolia scan, right? So head over to this URL, connect your MetaMask, and mint your own badass dev NFT because I mean you guys are badass. It's been over 2 hours on the class already, so mint your badass NFT and just send the link to it on the group chat.
Excuse
So
me,
can we do
sir.
that? Okay.
Excuse me, sir. Sir, can you hear me?
Okay, I can hear you, Suntoju.
Yeah. You said I can call back your attention when I create my Pinata account, right? Hello.
Yeah.
Yeah, I've created my account and I have uploaded my files. So please, can you like get me through? Please, 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 please.
All right. So after creating your account and uploading your file, what I said is copy your CID for your image. That's the first step. Copy your CID for your image. Set your VS code and paste it in here in your image section. Add your image here. Then after doing that, go back there, upload your full metadata, right? If you've not uploaded it, upload it. After you upload it, just copy it, right? And for you to mint another NFT, it's very simple. You need for you to mint your NFT, metadata.json, right? So you can configure your own metadata to be anything. You can decide to add your name here instead of badass, right? You can sorry here. For example, let's say I want to mint an NFT with Darlington, right? So Darlington is like let's say I want to mint a badass developer NFT called Darlington. I will copy my meta. I will have to upload this metadata again. This metadata now that I just changed now with Darlington. I'll come here, add file, and I'm going to upload it. So I'm going to come here. I'm going to drag it from here, and I'm going to drop it. And I'm going to name it Darlington. Let's just call it Darlington or JSON, right? And I'm going to upload it. Now it's going to take time to upload, but once it gets uploaded, right, I can just simply copy the content identifier and go mint another NFT on the Pascal. So did you follow that?
Yes, sir.
All right. So, Ezekiel, do you have any question? Because I guess we'll be rounding up very soon now. So, but before we round up, right? I gave us a task. I said, copy meta.json edit it, add your name here, add your name here, then upload it to Pinata. That's the first. Upload it to Pinata. Then copy your metadata, your CID for your metadata, right? Then go to Etherscan and go and mint your own badass dev NFT. Can we just do that? Can we do that?
So I've uploaded the metadata that justifies. So what's next, please?
Copy the CID and go and mint on your badass dev NFT contracts you already deployed.
Okay, how do I do that, please? Connect.
Right, guys, because of time and because of how horrible network is, I think we'll be rounding up the classes here. For any more questions you have, please ask on the group chat. We're already way out of time and my throat's already dried up. I need to get something to eat. So if you have any more questions, please ask on the group chat and I'll try to attend to you. And I gave us like a very simple task, right? I said let's assume this is the classwork, right? For attend this is the classwork for attending the class. So head over to the link I just sent now. I'm going to paste it on the WhatsApp group chat. Head over to this link, right? And make your own NFT smart contract. Customize your metadata, add your own name to it. So instead of Darlington, put Ezekiel, put some Tochuku, put your own name here. Then upload your metadata. If you've not created an account, create an account, upload your metadata to Pinata, then go to Sepolia and mint your own badass NFT. So come here, paste in your token URI. Remember to put IPFS // in front of your content ID. Paste in your content ID and mint your NFT. And I think that will be it for tonight. Thank you so much, guys, for staying up to this point. I think we'd call it a day here.
Thank you, sir.
Sir, excuse me. Is this a take-home assignment or just a task on our own? Hello, can you hear me? Oh.
Yeah, it's more like a classwork. So just do it, and before the end of
Sorry, sir. Don't we need to deploy the NFT contract before we can do it?
Please, did he say before the end of tomorrow?
Sir, we can't hear you.
Hello, what is happening? Now no one leave call again. Hey.
Guy, this is your mic.
Please, did
Omo.
anybody hear? He said before the end of what, please?
He did not give a time frame. I don't think he gave a time frame.
Okay, let's assume
Omo,
before the end of tomorrow
this
then.
chat is
Because
still
it's very
recording,
close.
oh. Oh wow, today class.
I think it will be edited.
But wait, oh, if the class is still recording, who is going to stop the recording?
As the thing shock me.
Okay, now leave class.
Maybe,
Yeah.
maybe if you should all leave, it would stop recording or something.
I beg, make na call admin, make it go stop record.
Ezekiel,
Hey
because of
God.
you, I don't remove earpiece.
As in,
When I don't want come out.
wanna come up now.
Please, who has
When I get
minted
that
the
tax.
NFT?
Now which I want ask, who don't mean that thing?
So for us to mint that NFT, we need to deploy the NFT contract, which we've
Yes.
not been
I
able
don't
to
deploy
deploy the
my
contract. You
No,
don't
no,
know.
you don't need to deploy the NFT contract. All you need to do
you
is
need to
just
deploy
create
the contract.
the metadata, then push it to IPFS or Pinata. Then take the link to Etascan, mint your own.
It seems we need the recording. Guys, please let's leave the call.
If you don't want leave come, una leave come now.
Okay, once we leave the call, the class will stop recording.
Wait, seriously, this is the record though.
It's still recording up to now.
You like
And
said,
it's going to increase the amount of data I will length or whatever.
um, sure, we just disconnect. Next time I go use it, I go use it and do something. Like I go do some stuff. When I go
Ayana, Ezekiel, Ayana, good night.
Good night, bro.
Still recording.
Guy, you know one leaf call. Good night, sir.